This video will cover the geometry review from day 1 and the 2 4-point short answer questions, 32 and 33. Alright, so 32 says, in the diagram below, EF intersects A, B, and CD at G and H respectively. GI is drawn such that GH is congruent to IH. If the measure of angle EGB is 50 and the measure of DIG is 115, explain why AB is parallel to CD. So we're going to work to get some other angles in this picture in order to hopefully explain and justify why AB is parallel to CD. So when I look at this, I know automatically that I can find this angle here, HIG. And that's because angles on a line sum to 180. So if I do a little bit of math off to the side, 180 minus 115, I find out that that angle is 65 degrees. So now because I just put an angle measurement in my picture, I have to make a statement about it off to the side. Measure of angle GIH equals 65 degrees because angles on a line equal 180 degrees. And then I stare at this picture and I see that I have two sides marked congruent. This side is congruent to this side in a triangle. So that means this triangle must have two congruent angles because it's isosceles. So here, the two congruent angles are across from the two sides that are congruent, meaning this angle is now 65 degrees. So my next step is to talk about it. And this is because isosceles triangles have two congruent sides and angles. So we're getting there. We just want to find a couple more probably in order to help us figure this out. When I have a triangle, I know that the angles sum to 180, so I think we can find the one in this placement here, GHI. So to find that, I'm going to add the 2, 65 plus 65 to get 130, and then I'll subtract that away from 180. So I found out that the measure of angle GHI equals 50 because angles in triangle equal 180 degrees. So when I look at this, I notice that I have two angles, both of 50 degrees. Right here and right here. And those angles have a special relationship. Oops, don't want the highlighter anymore. If I have two angles that are in the same position, right, that's exactly what's happening here, on parallel lines, then I know that they're called corresponding. And because one's on the upper parallel line and one's on the lower parallel line, that helps us prove the lines are parallel by saying AB is parallel to CD because corresponding angles are congruent. Now we could have done this in a different way and found out that these two angles here are congruent because they're vertical, and therefore the lines are parallel because of alternate interior angles being congruent. Or we could have done other things like alternate exterior angles. There's a variety of options for proving that the lines are parallel. So again, that was a 4-point question. Typically it's a point per step. If you flip it over, we've got another 4-point question, number 33. We have a quadrilateral that is given as a parallelogram with diagonals AC and BD intersecting at E. And our goal is to prove that triangle AED, I'm going to outline this and you should too so it stands out, is congruent to triangle CEB. So we have to use properties of parallelograms in order to help us prove that this is in fact, or that these are in fact congruent triangles. So when I look at this, I see that I have opposite sides AD and BC that are congruent to each other. So that'll help us, but we can't forget to use the given. So you're supposed to write out that entire thing, quadrilateral, blah, 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 and then I would say because given. Now, typically, we do T-chart proofs where we have statement, and then we have reason. But I'm going to do a because proof, because I think some of you guys like to do this type better. And if you like the statement and reason type proof, I'm going to do the statements in purple and the reasons in blue, so it's easy enough for you to follow along. So second step is to say that, again, AD is congruent to BC. And this is because opposite sides in a parallelogram are congruent. We also know something special about the pieces of the diagonals. This piece AE is congruent to this piece CE. ED is congruent to EB. So we're going to state that. EB congruent to ED, and AE congruent to CE. And this is because something about the diagonals. Diagonals in a parallelogram cut each other in half or bisect each other. So when I look at my picture, in order to prove triangles congruent, we have to have like side angle side, or AAS, ASA, SSS, or HL. When I look at my picture, I currently have a side, and a side, which means the triangles are congruent by SSS in this case. Triangle AED congruent to triangle CEB. And that's because side, side, side. Now I want you to understand that there are many ways to prove this. We could have also talked about these lines being parallel to give us alternate interior angles congruent. Or we could have talked about vertical angles being congruent. So there are many different ways to prove these two triangles congruent. In fact, you can do it by any of these first four methods, just not HL, because we don't have right angles. The next part says describe a single rigid motion that maps triangle AED onto CEB. So in other words, I have to be able to map angle A onto C because of this statement here. A goes onto C. Or I have to map D onto B. So hopefully you're recognizing that it is a rotation around E of 180 degrees. It's around E because E is actually what stays the same. That's the center of the rotation. So it's like we have a pin stuck in E so that it cannot move. And then the rest of it gets turned around a bit. Come back for the next video to check out the last question. Short answer, 6 points, ready to go.